Welcome to free online classes of physics with Lambor sir. So in the previous lecture we studied organ pipe and its types. There are two types of organ pipes. An organ pipe or tube is a device which encloses air column. And we come to know that there are two types of air columns. An air column in a pipe closed at one end, and second is the air column in a pipe open at both ends. And when that air column vibrates, that time longitudinal stationary waves are produced in the form of nodes, antinodes and loops. And when longitudinal stationary waves are formed due to vibrations of air column either in a pipe closed at one end or in a pipe open at both ends. That time boundary conditions are satisfied. And boundary condition is that nodes are always formed at closed end of the pipe and antinodes are formed at open end. And that time we come to know that there is a end correction. So we studied concept of end correction because antinode is not exactly formed at the open end of the tube but little distance above it, and Reynolds has given that end correction. And finally we find the corrected length of air column for a pipe closed at one end and for a pipe open at both ends. So as there are two types of air columns, so in this lecture let us learn vibrations of air column in a pipe closed at one end. And when any air column vibrates, that time longitudinal stationary waves are formed or produced. So we can form longitudinal stationary waves in two ways. First, by vibration of air column in a pipe closed at one end. So while studying this vibration of air column in a pipe closed at one end, we will see that if longitudinal progressive waves are sent along the air column in a pipe closed at one end by holding a vibrating tuning fork near the open end, then that waves get reflected at the closed end. Thus, air column contains the incident and reflected longitudinal waves, which interfere with each other and longitudinal stationary waves are produced. आता या पॅरेग्राफचा जो मिनिंग आहे तो मिनिंग समजावून घेण्यासाठी let us go through this diagram. So in this diagram we have considered a pipe closed at one end and the air column is enclosed in a pipe closed at one end. And this air column is vibrated with the help of this external periodic force. So vibrating tuning fork is held near the open end of this tube. And from this vibrating tuning fork, longitudinal progressive wave, that means sound waves, travels along this air column. And at the another end, that means at the closed end, that sound waves are reflected. So this air column contains incident sound waves and reflected sound waves, which are exactly in opposite direction, traveling through the same air column. And these two longitudinal progressive waves, that means sound waves, interfere with each other and longitudinal stationary waves are produced inside that air column. And these longitudinal waves, when they are formed, longitudinal stationary waves, when they are formed by satisfying boundary condition, at the closed end node is formed, and at the antinode, at the open end, antinode is formed. But according to Reynolds, this antinode is not formed exactly at the open end, but it is formed a little distance above the open end. And that distance of that antinode from the open end of that tube is called as the end correction. आणि याचा theoretical formula आपल्याला रेनॉल्ड दिलेला आहे. End correction E equal to 0.3 into D. आता इथं हा जो closed end आहे या पाईपचा, this closed end acts as a rigid wall त्यामुळं ह्या क्लोज्ड एंड जवळ असणारी जी एअर पार्टिकल्स आहेत, that air particles are not free to vibrate. So, node is formed at the closed end of that tube. And particles of air at the open end are free to vibrate. That's why antinode is formed at the open end of that tube. That written in this paragraph. See here, the closed end acts as a residual. The air at the closed end is not free to vibrate and hence node is formed at the closed end. But air at the open end is free to vibrate. So an antinode is formed at the open end. So this air column, which is enclosed in a pipe closed at one end, can vibrate under this boundary condition. What is that? Node is always formed at closed end and antinode is always formed at open end. So let us go through the boundary condition. So when longitudinal stationary waves are produced in a pipe closed at one end, पाईप क्लोज्ड ॲट वन एंड मधील एअर कॉलम व्हायब्रेट झाल्यानंतर ज्या लॉन्जिट्युडनल स्टेशनरी वेव्स प्रोड्यूस होतील, त्या लॉन्जिट्युडनल स्टेशनरी वेव्स प्रोड्यूस होत असताना द एअर कॉलम can vibrate in different ways with different frequencies subject to boundary condition. What is that? A node is formed at closed end and antinode is formed at the other end किंवा open end. So this is the boundary condition, and satisfying this boundary condition, air column can vibrate in different ways with different frequencies. Let us go through the three different ways of vibrations of that air column. See here, we have considered three air columns of same length. म्हणजे या ठिकाणी तिन्ही डायग्राम मध्ये जी पाईप किंवा ट्यूब कन्सिडर केलेली आहे, सेम लेंथ आणि सेम इनर डायमीटरची तिन्ही ट्यूब्स आहे. पण तिन्ही ट्यूब मधला एअर कॉलम जो व्हायब्रेशनचे मोड आहेत दॅट आर डिफरंट. इन फर्स्ट डायग्राम air column is vibrating with forming only half loop. In second diagram, air column is vibrating with forming 1.5 loop. And in the third diagram, air column is vibrating with forming 2.5 loop. आणि तिन्ही प्रकारच्या मोड ऑफ व्हायब्रेशन मध्ये बाउंड्री कंडिशन सॅटिस्फाय झालेली आहे. And what is that boundary condition? In case of pipe closed at one end, boundary condition is that at closed end, node is formed and at the open end, antinode is formed. मग ज्या डिफरंट वेज न हा एअर कॉलम व्हायब्रेट होतोय त्या डिफरंट वेज लाच आपण म्हणायचं मोड्स ऑफ व्हायब्रेशन्स ऑफ एअर कॉलम. सो द डिफरंट वेज इन विच द एअर कॉलम कॅन व्हायब्रेट आर कॉल्ड मोड्स ऑफ व्हायब्रेशन्स ऑफ द एअर कॉलम. आणि हा जो एअर कॉलम आहे that can vibrate under this boundary condition, forming node at the closed end and forming antinode at the open end. आणि ज्या डिफरंट वेज न हा एअर कॉलम व्हायब्रेट होतोय त्यालाच तुम्ही मोड्स ऑफ व्हायब्रेशन्स ऑफ द एअर कॉलम. सो लेट अस लर्न मोड्स ऑफ व्हायब्रेशन ऑफ एअर कॉलम इन अ पाईप क्लोज्ड ॲट वन एंड. आणि कोणत्याही मोड ऑफ व्हायब्रेशन मध्ये एअर कॉलम व्हायब्रेट होत असताना boundary condition satisfied होणार. So first three modes of vibration of the air column in a pipe closed at one end are shown in the figure. म्हणजे air column can vibrate in different ways with different frequencies. त्यापैकी first three ways air column च्या व्हायब्रेशनचे आपण या डायग्राम मध्ये रिप्रेझेंट केलेले आहेत. Let us go through the diagram showing the first three modes of vibrations of air column. So figure A is the first mode of vibration. Figure B shows the second mode of vibration and figure C shows the third mode of vibration. Number of modes vibration चे air column चे possible आहे, but we have considered here only first three modes of vibration. In first mode, the air column is vibrating with forming only half loop. In the second mode, air column is vibrating with forming 1.5 loop. And in the third mode, the air column is vibrating with forming 2.5 loop. And in each mode, boundary condition is satisfied. In each mode, boundary condition is satisfied. Node is forming at closed end and antinode is formed at the open end. In this diagram, this small l is the length of the pipe or tube. Or we can say that length of air column enclosed by the pipe or tube. So in this diagram, small l, length of air column in pipe, किंवा तुम्ही म्हणू शकता लेंथ ऑफ पाईप. आणि हे जे ई आहे, दिस इज द एंड करेक्शन ऍट द ओपन एंड. कारण रेनॉल्डचं म्हणणं आहे, हा जो अँटीनोड आहे, इट इज नॉट फॉर्म एक्झॅक्टली ऍट द ओपन एंड ऑफ दॅट पाईप, बट इट इज फॉर्म लिटल डिस्टन्स अबाव दॅट ओपन एंड. मग त्या अँटीनोडचं डिस्टन्स फ्रॉम द ओपन एंड ऑफ दॅट पाईप इज द एंड करेक्शन. And this end correction plus length of this pipe gives you corrected length of air column. And in this case, V is the velocity of sound in air. हा जो air column आपण व्हायब्रेट करतोय, pipe closed at one end चा, तो air column व्हायब्रेट करण्यासाठी आपण vibrating tuning fork is held near the open end of that pipe. आणि त्या tuning fork पासून ज्या sound waves travel होतात एअर कॉलम मध्ये, त्या साऊंड वेव्हची व्हेलॉसिटी इज v, velocity of sound in air. And in that diagram, n stands for node and a, capital A, stands for antinodes. So let us learn one by one mode of vibrations of that air column. So first of all, we will study fundamental mode of vibration or first mode of vibration, which is also called as first harmonic mode. So this air column may vibrate with one half loop only. फक्त एक हाफ लूप व्हायब्रेट करून जर एअर कॉलम व्हायब्रेट होत असेल, तर त्या मोड ऑफ व्हायब्रेशनला तुम्ही फर्स्ट मोड ऑफ व्हायब्रेशन किंवा फंडामेंटल मोड ऑफ व्हायब्रेशन म्हणू शकता. आणि करस्पॉन्डिंग जी फ्रिक्वेन्सी आहे व्हायब्रेशनची, that frequency is called as a fundamental frequency or first harmonic frequency. So the air column may vibrate with one half loop, and this mode of vibration is called fundamental mode of vibration, and the corresponding frequency is called fundamental frequency, and this fundamental frequency is our first harmonic. So let us go through the diagram explaining the fundamental mode of vibration. See here, in this diagram, the air column enclosed in a pipe closed at one end is vibrating with half loop only. And त्यावेळी closed end ला node form होत आहे, open end ला antinode form होत आहे. आणि या mode of vibration ला तुम्ही fundamental mode of vibration म्हणा, आणि corresponding जी frequency आहे vibrationची, त्याला फंडामेंटल फ्रिक्वेन्सी म्हणूया किंवा फर्स्ट हार्मोनिक म्हणूया. इन दिस डायग्राम, या मोड ऑफ व्हायब्रेशनची जी फ्रिक्वेन्सी आहे, फंडामेंटल फ्रिक्वेन्सी आहे, ती आपण स्मॉल n ला डिनोट करूया. फंडामेंटल फ्रिक्वेन्सी फॉर द फंडामेंटल मोड ऑफ व्हायब्रेशन, अँड लॅम्बडा वेवलेंथ फॉर फंडामेंटल मोड ऑफ व्हायब्रेशन. फ्रॉम दिस फिगर ए, या फिगर ए मधून एअर कॉलमची जी लेंथ आहे, त्या एअर कॉलमच्या लेंथ मध्ये हाफ लूप फॉर्म झालेले आहे, आणि हाफ लूपची लेंथ आहे ती लॅम्बडा बाय 4 असते. सो कॅपिटल एल इज द लेंथ ऑफ एअर कॉलम, करेक्टेड लेंथ ऑफ एअर कॉलम, which is equal to small l plus e. Small l is the length of column in the pipe, length of air column in the pipe or length of the pipe, and this e is the end correction, and this corrected length is equal to length of half loop. So length of air column L is equal to length of half loop lambda by 4, आणि यावरून तुम्ही लॅम्बडा इक्वल टू लिहू शकता 4m. आता आपल्याला माहिती आहे रिलेशन बिटवीन व्हेलॉसिटी, फ्रिक्वेन्सी अँड वेवलेंथ, v इक्वल टू n लॅम्बडा. फ्रॉम दॅट रिलेशन, फ्रिक्वेन्सी ऑफ व्हायब्रेशन ऑफ फंडामेंटल मोड आपण लिहू शकता n इक्वल टू v अपॉन लॅम्बडा. And in this equation, lambda we can substitute equal to 4L. See here, that is equal to V upon 4L. आणि हे जे L आहे, हे L हे करेक्टेड लेंथ आहे आणि यामध्ये लेंथ ऑफ पाईप प्लस एंड करेक्शन येणार. That's why you can see here, therefore N equal to V upon 4L, and this L is equal to small l plus e. So this is expression for fundamental frequency of vibration of that air column, which is called as the first harmonic, N equal to V upon 4L. So therefore fundamental frequency is first harmonic, and this is called fundamental frequency and also called as first harmonic frequency. आता इथं आपल्याला सर्वांनाच माहिती आहे, कमीत कमी हाफ लूप फॉर्म करून हा एअर कॉलम व्हायब्रेट होऊ शकतो. लेस दॅन दॅट इट इज नॉट पॉसिबल. That's why this is the lowest frequency. Fundamental frequency is the lowest frequency the air column can vibrate. That's why we have written one statement here. Fundamental frequency, this is means fundamental frequency is the lowest frequency with which an air column can vibrate. म्हणजे air column enclosed in a pipe closed at one end can vibrate with this lowest frequency, which is equal to V upon 4L. That's why it is the fundamental frequency, and fundamental frequency is our first harmonic. So this was the fundamental or first mode of vibration. So let us learn second mode of vibration. See here, second mode of vibration, which is also called as first overtone mode. And depending upon which multiple of fundamental frequency, maybe third, second, fourth or fifth harmonic, इथं फर्स्ट ओव्हरटोन फ्रिक्वेन्सी आपल्याला थर्ड हार्मोनिक मिळते. आणि या सेकंड मोड ऑफ व्हायब्रेशन मध्ये एअर कॉलम is vibrating with 1.5 loop. See here, the air column may vibrate with 1.5 loop. That time this mode of vibration is called first overtone mode of vibration, and the corresponding frequency is called first harmonic frequency. पण इथं कितवा हार्मोनिक येणार, that depends upon which multiple of fundamental frequency results in this case. त्यामुळे सेकंड मोड ऑफ व्हायब्रेशन मध्ये एअर कॉलम 1.5 लूप फॉर्म करून व्हायब्रेट होतोय. सो लेट अस गो थ्रू द डायग्राम एक्सप्लेनिंग द सेकंड मोड ऑफ व्हायब्रेशन. सी हियर, दिस एअर कॉलम is vibrating with 1 loop and half loop, satisfying boundary condition. Means there are total 3 half loops are formed. And once again here, small l, length of air column in the pipe, and this small e is the end correction, and corrected length, capital L, is the length of air column, which is equal to 3 times lambda 1 by 4, म्हणजे 3 times half loop आहेत म्हणून. So in this second mode of vibration, जी फ्रिक्वेन्सी आहे त्याला फर्स्ट ओव्हरटोन फ्रिक्वेन्सी म्हटलाय. That's why N1 is the first overtone frequency, which is different from the fundamental mode of vibration. And corresponding जी wavelength आहे फर्स्ट overtone frequency ची, ती आपण lambda 1 दाखवूया. Lambda 1 wavelength of first overtone mode. So from figure B मधून एअर कॉलमची जी लेंथ आहे कॅपिटल L, ह्या लेंथ मध्ये 3 हाफ लूप्स फॉर्म झालेले आहेत आणि एका हाफ लूपची लेंथ ही लॅम्बडा 1 by 4 आहे. That's why length of air column, capital L, equal to 3 times lambda 1 by 4. आणि यावरून तुम्ही lambda 1 लिहू शकता 4L upon 3. lambda 1 equal to 4L upon 3. आता आपल्याला जर फ्रिक्वेन्सी ऑफ व्हायब्रेशन काढायची असेल तर आपल्याला व्हेलॉसिटी माहिती आहे साऊंड वेव्हची, वेव्हलेंथ माहित झाली, then we can find frequency of vibration of first overtone mode, N1 equal to, see here, N1 equal to V upon lambda 1. इथं V1 का झालं नाही, तर velocity of sound in this air same medium असल्यामुळे सेम असणार velocity. Now we can substitute lambda 1 as 4L by 3. That's why you will get V upon 4L by 3. आता इथं हे जे 3 आहे डिनॉमिनेटरला ते न्यूमरेटरला आल्यानंतर तुम्हाला मिळेल 3 into v upon 4l. Let us see this. Therefore n1, which is the first overtone frequency, equal to 3 times v upon 4l. आता इथं जे l आहे ती करेक्टेड लेंथ आहे. त्या करेक्टेड लेंथ मध्ये लेंथ ऑफ एअर कॉलम इन पाईप स्मॉल l प्लस एंड करेक्शन तुम्ही घेतला. आणि हा जो फॉर्म्युला आहे v upon 4 into bracket l plus e किंवा v upon 4l, this is nothing but fundamental frequency small n. So you can write here n1 equal to 3l, and this n1 is the frequency of vibration of second mode, which is called as the first overtone frequency, and which is equal to 3 times fundamental frequency. म्हणजे third multiple of fundamental frequency, which is called as a third harmonic. That's why frequency of first overtone म्हणजे n1, frequency of first overtone n1 is equal to 3 times fundamental frequency. And third multiple of fundamental frequency is nothing but third harmonic. That's why you can say that first overtone frequency is called third harmonic. So in this way we find the expression for frequency of vibration for the second mode of vibration. आणि सेकंड मोड ऑफ व्हायब्रेशन मधील फ्रिक्वेन्सीला तुम्ही फर्स्ट ओव्हरटोन फ्रिक्वेन्सी म्हटलात अँड ऑल्सो कॉल्ड एज थर्ड हार्मोनिक बिकॉज इट इज 3 times fundamental frequency. So let us go through the third mode of vibration. Third mode of vibration. And third mode of vibration ला तुम्ही सेकंड ओव्हरटोन मोड म्हणू शकता किंवा फिफ्थ हार्मोनिक म्हणू शकता. And in this third mode of vibration, the air column may vibrate with 2.5 loop. See here, the air column may vibrate with 2.5 loop. That time, this mode of vibration is called second overtone mode of vibration, and the corresponding frequency is called second overtone frequency. आता harmonic कितवा येणार, that depends upon which multiples of fundamental frequency arises here. So let us see which harmonics comes here. So in this third mode of vibration, air column is vibrating with 2.5 loops. So let us go through the diagram explaining third mode of vibration. See this. In this diagram, air column is vibrating to form longitudinal stationary waves with 2.5 loops. Means in all there are 5 half loops. In this diagram, small l, length of air column in the pipe, small e, once again the end correction at the open end, and here capital L is the corrected length of air column, and that corrected length of air column मध्ये 5 half loops form झालेले आहेत. त्यामुळे capital L equal to आपण लिहिले 5 into lambda 2 by 4. So in the third mode of vibration, जी फ्रिक्वेन्सी आपण घेणार that will be different from the fundamental mode, second mode of vibration, and that frequency we will consider here n2. See here, n2 is the third frequency of third mode of vibration, which is second overtone frequency. आणि त्यावेळची जी वेवलेंथ असेल ती लॅम्बडा 2 घेऊया आपण. वेवलेंथ लॅम्बडा 2, वेवलेंथ ऑफ सेकंड ओव्हरटोन मोड. सो फ्रॉम फिगर सी, या फिगर सी वरून आपल्याला एअर कॉलमची जी करेक्टेड लेंथ आहे त्या एअर कॉलमच्या लेंथ मध्ये 5 हाफ लूप्स फॉर्म झालेले आहेत. दॅट्स वाय लेंथ ऑफ एअर कॉलम कॅपिटल एल इक्वल टू 5 टाइम्स लॅम्बडा 2 by 4. आणि यावरून लॅम्बडा 2 ची व्हॅल्यू तुम्हाला मिळेल. सी हियर, देअरफॉर लॅम्बडा 2 इक्वल टू 4l upon 5. आता लॅम्बडा 2 आपल्याला माहित झालं, त्यावरून तुम्ही second overtone frequency काढू शकता. See here, frequency of vibration of second overtone mode, that is n2 equal to v upon lambda 2. We can substitute lambda 2 here. So you will get v upon 4l upon 5. This 5 will be at the numerator. So next step will be like this. n2, frequency of second overtone mode, n2 equal to 5 times v upon 4l. आणि नेक्स्ट स्टेप मध्ये आपण ही कॅपिटल एल ची करेक्टेड जी लेंथ आहे दॅट इज इक्वल टू एल प्लस ई सबस्टिट्यूट केलेला आहे. And this V upon 4L is nothing but the fundamental frequency small n. That's why we can write N2 equal to 5N. And in this equation, N2 is your second overtone frequency. Your frequency of second overtone mode, which is equal to 5 times fundamental frequency. And this is the fifth multiple of fundamental frequency called as the fifth harmonic. So we can write here frequency of second overtone is equal to 5 times fundamental frequency, which is nothing but fifth harmonic. Thus, second overtone frequency is also called as fifth harmonics. So in this way, vibrations of air column in a pipe closed at one end is vibrating with frequencies N, 3N, 5N. नेक्स्ट फ्रिक्वेन्सी आहे ज्या व्हायब्रेशनच्या तिथे तुम्हाला 7N मिळेल, 9N मिळेल. म्हणजे सगळी ऑड हार्मोनिक्स आहेत. कारण फर्स्ट मोड ऑफ व्हायब्रेशन मध्ये आपल्याला फर्स्ट हार्मोनिक मिळालं, सेकंड मोड ऑफ व्हायब्रेशन मध्ये आपल्याला थर्ड हार्मोनिक मिळालं, थर्ड मोड ऑफ व्हायब्रेशन मध्ये आपल्याला फिफ्थ हार्मोनिक मिळालं. आता फोर्थ मोड जर आपण स्टडी केला असता तर तिथे आपल्याला सेवेंथ हार्मोनिक मिळालं असतं. सो दीज आर द फ्रिक्वेन्सीज ऑफ व्हायब्रेशन ऑफ एअर कॉलम enclosed in a pipe closed at one end. And from that frequencies, we can find some conclusions. Which are the conclusions? First, an air column in a pipe closed at one end vibrates with frequencies at the fundamental mode frequency N, which is equal to V upon 4L. Then the second mode of vibration frequency 3N. थर्ड मोड ऑफ व्हायब्रेशनची फ्रिक्वेन्सी 5N. फोर्थ मोड ऑफ व्हायब्रेशनची फ्रिक्वेन्सी आपल्याला मिळेल 7N, 9N, 11N एक्सेट्रा. आता ही जर तुम्ही हार्मोनिक्स चेक केलात तर फर्स्ट हार्मोनिक, थर्ड हार्मोनिक, फिफ्थ हार्मोनिक, सेवेंथ हार्मोनिक, we can conclude that only odd harmonics are present in the vibrations of air column enclosed by pipe closed at one end. So therefore, only odd harmonics are present in the vibrations of air column in a pipe closed at one end. त्यानंतर third conclusion, आपण frequency of pith overtone काढायची. Frequency of pith overtone. आपल्याला माहिती आहे फर्स्ट overtone ची frequency N1 equal to 3N. सेकंड overtone ची frequency N2 equal to 5N. यावरून pith overtone ची frequency आपल्याला काढायची असेल तर NP equal to twice P plus 1 ब्रॅकेट मध्ये twice P plus 1 into N. आता या फॉर्म्युला वरून फर्स्ट ओव्हरटोन ची फ्रिक्वेन्सी जर घ्यायची असेल तर P equal to 1 लिहावं लागेल. N1 equal to 2 into 1 म्हणजे 2 plus 1 3N झालं. सेकंड ओव्हरटोन ची फ्रिक्वेन्सी जर घ्यायची असेल तर P equal to 2 लिहावं लागेल. सो N2 equal to 2 into 2 4 झालं plus 1 5N. So in this way you can find frequency of pith overtone using this formula. And in this formula, P takes the value. या P च्या व्हॅल्यू तुम्ही 1, 2, 3 etc. घेऊ शकता. Where P takes the value 1, 2. And N is nothing but fundamental frequency. N is fundamental frequency whose formula is V upon 4N. So in this way, we studied vibrations of air column in a pipe closed at one end and its first three mode of vibration. आणि ज्यावेळी एखाद्या पाईप मधला किंवा ट्यूब मधला एअर कॉलम व्हायब्रेट होईल त्यावेळी तिथं longitudinal stationary waves फॉर्म होतील. So with this we are ending this lecture. Thank you friends.